Hello everyone, this is Prakash. Welcome to another day of our GNI learning series. Yesterday, in the previous video, we understand about the vector database and how data store and retrieve from the vector database. And today, in this video, we will understand the core fundamentals behind the data retrieval, like how data retrieve from the vector database based on the user context. Okay. First of all, what is vector embedding? I think you already knows about the embedding methods. Like it's the representation of the text into numbers, like your number representation of the text. Okay. So for an example, for king, the vectors differ based on the embedding model that you using. If you are using bot, then you probably have somewhere around 728. And if you are using GPT, then you'll have more dimension of the vector. So this is just the number representation of the text or inputs of your features. Okay, how vector find the similar vectors? Like there are two popular methods, like cosine similarity and Euclidean distance. Okay, so in this video we'll understand about the concept of Euclidean distance and cosine similarity. So first, let's understand what is Euclidean distance. So guys, basically Euclidean distance is the distance between two points, two data points. Okay, let's say you have two vectors, then it's the distance between the data points present in the vectors. Okay, for an example, let's say you have a vector A and B, and A is 1, 2, and B is 4 and 6. It's just the distance between these two vectors. Like how you can calculate it? Yeah, well, the mathematical formula, use the Pythagoras formula for the distance calculation, which is your like 4 minus 1 or the whole square plus your 6 minus 2 whole square, and then you have the square root. So in that way, we'll calculate the distance between 2 points or two vectors. Okay, and basically, equivalent distance will give you the magnitude. Okay, like it will not give you the direction; it will give you the magnitude between 2 points. Okay, and it can range up to 0 to infinity. Then next is our cosine similarity. Well, cosine similarity, you can say that in general, layman term, that the angle between two vectors. Okay, so if you have a very, if the angle between two vector is kind of near to 0, then you are likely to say that the vectors are in similar direction. Okay, so cosine similarity basically give you the direction of two vectors. It doesn't care about the magnitude. It only cares about the direction. Okay, so for an example, let's say you have two vectors A and B here, and A represent as 1, 2, 3, and B is 2, 4, and 6. Okay, so if you want to calculate the cosine similarity between these two vectors, first you do the dot product between A and B. Okay, so for this dot product, guys, it's very simple thing. Like you just multiply the numbers present here. Okay, 1 into 2, then 2 into 4, and 3 into 6. Then you add them up. So your dot product will be 2 plus 8 plus 18. Okay, and it will be 28. Okay, this is your 28, and then you divide it by the magnitude. Okay, the magnitude of these two vectors. How to calculate that thing? Well, you calculate the square of each numbers and find the square root of this. So for, let's say for example, this one, square of 1 is 1, square of 2 is 4, and square of 3 is 9. Okay, then your total number is 14. Then you calculate the square root. So it's more likely to end the range between 3 to 4. Okay, because 9 and 16. Okay, and this is the square of 3 and 16 is the square of 4. So you are mostly likely to get a number in between the range of 3 to 4. Okay, so here it is. And similarly, you calculate the magnitude of this vector. You get the number, and you do the like dot product divided by your magnitude. So you'll get the cosine similarity score or value. Okay, so here in this case, you can see that the cosine similarity score is 1. Okay, when it is 1 means so your cos theta. Okay, when the cos theta will be 1, well, you if you know the trigonometry, so cos theta will be 1 in the case of theta is equal to 0. Okay, so when your theta value is 0, your when the theta value is 0, like the angle between two vectors is 0, that means the vectors are perfectly similar. Okay, So when I say perfectly similar, it doesn't mean that it carries the same meaning. So it's perfectly similar in terms of direction. Like it doesn't care about the magnitude. It's only care about the direction. So when I say it's perfectly similar, that means in the direction. So you can observe A and B. You can say that B is equal to 2A. It's the proportion, okay? Like 1 into 2 is 2, then 2 into 2 is 4, and 3 into 2 is 6. So you can say that B is equal to 2A. That means they are in a similar direction. So it just gives you the context, okay, that they are in the similar direction. So now let's understand when to use which similarity source technique, okay. So like I mentioned, cosine similarity, it's more care about the semantic meaning. Okay, like for an example, I love dogs. I really love dogs. So both the sentence are pretty similar. I mean, both the sentence are pretty similar meaning. So just to find out the, I mean, to use the similarity source here, you can use cosine similarity. And when to use Euclidean? Well, when you want to cluster the neighbors points, because Euclidean it's give you the distance between 2 points, right? So when you want to cluster the data points or cluster your uh, like similar vectors, then you use Euclidean distance. Okay, so that's all for today, guys. Thank you.